Hey, it's been a while. I'm glad to have you back. Tonight we're going to be discussing combinations of circuits. Okay, here's our first problem. In this situation here, we've got what I would call a combination circuit, meaning it's got both parallel and series components to it. If we look at this, both resistor 5 and resistor 4, they are in parallel, meaning when the current comes through here, it's got a choice right now. It's got two different paths it can take. This first resistor, even though I've got it labeled here as resistor 1, it is in series. It's like our household. It's in a series circuit. If this one were to blow, no electricity could keep going, no current could keep going. The electrons would stop, and the other two would no longer be operational. Well, how do we do this then? Well, what we can do is we can take this circuit. I'm going to draw a mini circuit down here, a mini picture of it. Here's where we're at right now. This stopping point right here, we're saying is right here. And what we can do from this point is we can take these two circuits and combine them and rewrite this problem as if those two were in series, because we know that we can find a total resistance and act as if there was one resistor in the place of those two that are in series or in parallel. So how would we do that? Well, we would take these and use our parallel circuits. The total resistance for these two, right, or I guess a better one that we've been discussing it, would be is take these two resistors and find their total resistance by taking the inverse of them. And when we do that, we find that RT for these two turns out to be 12 ohms. So what that means is we can take these two resistors that are in series and we can replace them with a 12 ohm resistor. So what that gives us now is a 20 and a 12. Well, let's start going through here and finding the information that we have here. The RT then for the whole problem, if I were to be doing the chart, the voltage total is 30. We said that first step is always find the total resistance. Well, I've taken the big problem and I've simplified it now into a smaller problem. When we simplify things, we always try to simplify them into series. My total resistance would be 32 ohms. 20 and 12 would be 32 ohms. So this whole circuit is acting as if it's got one 32 ohm circuit. We now know the total resistance. We can find our total current. What we have here is 0.93 amps. Then is our, and how did I do that? I used our equation V equals I times R. And I said 30 volts equals I times 32. And then of course I turned out to be 0.93 amps. So what have we done so far? We took this whole circuit that was in series and parallel, and we started making it into just a series circuit. We started simplifying it by turning it into a series circuit. So we took a circuit that was in parallel and series. Here's my battery and a circuit, and then it had a resistor, and then over here was another resistor. So that was a combination. We went from there and said, okay, here's my battery. There's a series. We took these two and we rewrote this problem as if it had one resistor in place of those two. From there then, we combined these two and said we could act as if this whole circuit just had one resistor. So this one here was a 20 ohm resistor, this one here was a 20, and this up here was a 30. We combined these then and said that was a 20 and a 12, and then we went to a 32. And that allowed us to be able to fill in our chart, or start our chart. So what I've created here is our chart. Hopefully you're with us to that point. Now I'm going to go back to the circuit that we have. We're going to start trying to fill in all of these components that we know. What we know right now is that this circuit is acting as if it's in series up till this point. Well, how much current do we know that's going through it here at this point? This is that third step where we take what we know, use our concepts. We know that the current is the same in a series circuit. So up through here, with a series circuit, where this is a series circuit, we know that this is getting that set amount of current. So let's use that. Okay, at this point we said that resistor 3 up here, this one up here, this first one, was going to be giving us, was in series. I know that in a series circuit they all get the same current. So I'm going to put 0.93 amps. I can't put that for resistor 4 and resistor 5 because they're hooked up in parallel. So right here the current's going to split. But I do know that this is 0.93 amps. Because of that, I now know I and R, use the equation, find V. What we get here then is 18.6 volts. 20 times 0.93 is 18.6 volts. That means there is a 18.6 volt drop right here. There was 30 volts at this point. It loses 18.6 volts because they're used right here, and that leaves us then with a total of 11.4 volts. Well, what do we know about then in a parallel circuit? This 11.4 volts, both circuits in a parallel circuit are going to get those 11.4 volts. Again, we're left then with our equation, V equals I times R. If I take 11.4 and divide it by 30, and take 11.4 and divide it by 20, that's going to give me I4 and I5. As we look here now, we've got the chart filled in. We have 0.93 amps at the beginning. When these two circuits come back together, these two currents are going to come back together. And if you take 0.38 and 0.57, we get 0.95. Once again, we're only off by 2/100ths. It's undoubtedly a difference in rounding, but our currents add up to be the same. And it's the same throughout the whole process here. Alright, here's our next problem that we're going to work through. You can tell that we've got series through to here. We've got these two resistors here. And then down here on the bottom we have another one in series. So we have series, parallel, into series. So we've got to make some decisions here. We're going to have to put this together as a total resistance. That first step is always to find the total resistance. Well, let's go about using what we know. This part of the circuit right here, the total resistance would be found by simply adding them because they're in series. So these two right here, we can pretend as if that's one 15 ohm resistor. These two circuits right here are in parallel. How do we rewrite those? We take the inverses of them. That turns out to be 7.5 ohms. The next step then is to take our last one of this 4 ohms, and now they're all in series because we've replaced these two with 1. We've replaced these two with 1. So in essence now we've got this one, and this one are all in series. Let me draw a picture of what we're talking about here. Okay, the steps that we went through here is I've drawn them. This was our first original circuit. We had these two that were in series right here. Well, we combined them by simply adding them, and we said that the 5 ohm and the 10 ohm gave us a 15 ohm resistor here. The next step, I've taken this and brought it down here, is we've taken these two that are in parallel. We said, okay, let's combine those and make it be as if there's one circuit there, one resistor there in series. And we said that 10 ohm and 30 ohm turned out to be a 7.5 ohm. This one we said was 15 ohms. So I had some mechanical difficulties there. This one up here we said was 15 ohms. And then this last one we know to be 4 ohms. What do we do with it if it's all in series? We'd add them up. So the first step we've gone through here is we found RT. And we would say that RT then is 26.5 ohms. The second step is to find IT. That's easy now. VT equals IT times RT. Okay, what I've done here now is I've went ahead and found IT, and that was 1.13 amps. What I want you to do, you're only going to have one problem to do here, is I want you to go ahead and try to fill out the rest of the chart. You've got 1, 2, 3, 4, 5 resistors here in this problem that we want you to try finding the voltage for, the current for, and the resistance is given to you. We've now given you the voltage and the current through each of these two, or through the whole thing. Now see if you can't find the voltages for each one and the currents for each one. We'll begin tomorrow's lesson with that. Hey, I'll see you on the flip side.